Hey Math 1B, I've got a new video for you. This is over the notes from 3.4. I was a little late getting them on there, but I want to make sure we've got it in Google Classroom, just in case you want to look back at it. So, this is sort of like the mountaintop of negative exponent properties. What are we supposed to do when you're distributing a negative exponent to all the parts inside here? Well, as you recall, first, let me write this a little bit larger. Let me write this again. So you got 4w to the negative 3 power, x to the 5, y to the negative 4. All of that is to the negative 3 power. On the bottom, you've got 2w squared, x to the 8, y to the negative 12, z to the negative 6, all of that to the 4. All right. Just make sure you're distributing that negative exponent to all these parts and to the 4 as well. Remember, the 4 has a 1 as its exponent. Now, what I mean by distribute it, is multiply the exponents times negative 3. So if you know your vocab, these little numbers here, those are the exponents. So you're going to do 4 to the 1 times negative 3. That's now 4 to the negative 3 power. W to the negative 3 times negative 3. Positive 9. X to the 5 times negative 3. And then y to the negative 4 times negative 3. So hopefully that all makes sense. I'm just multiplying little number times little number. Check out the bottom. The 4 is going to be distributed to the negative 6, to the negative 12, to the 8, to the 2, and to the coefficient 2. So remember, the 2 has technically it has an exponent of 1, so I'm taking that 4 times the 1 there. It's going to be 2 to the 4th power, w to the 2 times 4, x to the 8 times 4, y to the negative 12 times 4, and z to the negative 6 times 4. Now, before you do anything else, you need to understand that negative exponents don't really make sense until they become positive exponents. So what we do is we move the negative exponents to the opposite part of the fraction. So this 4 to the negative 3 power, if moved to the bottom, you get 4 to the positive 3. This will now be positive 15 down here. And the same goes for the negative exponents in the denominator. You move them to the top, they become positive. So, these reds, well, you guys can't see that, I don't think. These two reds move up top. These two reds move to the bottom. And notice their exponents completely change from negative to positive. Now, I'm going to take these originals and rewrite them where they are, because if it's a positive exponent, it should stay where it's at. So w to the 9, stay up top. W to the 8, stay on the bottom. 2 to the 4, stay on the bottom. Y to the 12, stay on top. And then you've got x to the 32, stay on the bottom. So the 2 positives stay up top, the 3 positives stay on the bottom. Okay, from there, you have to decide, are we multiplying powers, which means add the exponents, or are we dividing the powers, which means subtract them? Opposite parts of the fraction means subtract them. And then it should go in the spot where the bigger power lies. So you're going to have a w to the 1 power up top. The bottom, if you take 2 to the 4, you get 16. If you take 4 to the 3, you get 64. You're taking 16 times 64. Which should come out to be 384,046. 1,024 in the denominator. All right, so we took care of those. The x's are side by side in the denominator. That means we multiply them, which is the same as adding the exponents. So it's x to the 15 plus 32. Should be x to the 47 power. And then the same goes for the y's. Side by side means you add the exponents. So it's going to be 48 plus 12, 60. And then the z's, they're positive up top, so leave them up top. So a lot was going on there. Let's do a couple more examples to make sure we know the ins and outs of everything. All right, where's my eraser? So again, there's a very, very, very structured way about going. There's a very structured way about solving these down. Simplifying the expressions, we're always asking ourselves, what is going to be distributed to everybody? And then move the negative exponents. Okay, step one. Distribute the negative exponent to everybody. On both the top and the bottom of the fraction. So remember, there's a 1 for the 3 and a 1 for the 5 if there's no exponent listed. So you're going to get 3 to the 3 power, a to the negative 6 power, b to the 15 power, and then c to the negative 3 power. Again, I'm just multiplying little numbers times little numbers to get the new exponent. 5 to the negative 2 power, a to the negative 14 power, b to the positive 12 power, and then c to the negative 22 power. So at this point, you got to figure out who moves and who stays. Everybody who's not circled. So moving day, you know what? Before I do moving day, I'm just going to rewrite all the positive exponents where they're at. And in fact, I can do 3 times 3 times 3 right now. It's 27. So 27 stays up top. B to the 15 stays up top. B to the 12 stays on the bottom. Now I'm just going to put the top negative exponents on the bottom now. So it's going to be a to the positive 6 on the bottom, c to the positive 3 on the bottom. And then it's going to be 5 to the positive 2 up top, a to the positive 14 up top, and then c to the negative 22 is now c to the positive 22 up top. All right. All right, so if they're side by side, multiply. So this is going to be 27 times 5 times 5. It ends up being 675. If they're separated by the fraction, then you're actually going to subtract the 2. So that's going to be a to the 8 power. This is going to be b to the 3 power. And I'm keeping them up top because the bigger one's up top. And then the same thing goes with the c's. Subtract them, bigger power up top, so the final answer goes up top. And then if there's nothing left on the bottom, you can always put a 1 there. But technically it would be just as easy to say it's 675, a to the 8, b to the 3, c to the 19. So, I don't know. You could probably just box up that answer and not even put it over 1. All right. Seems like a lengthier process, but still not too bad. We got a 0 exponent on number 3. We've already talked about what 0 exponents mean. Anything to the 0 power is 1. However, if you didn't make that connection just yet, like say you're doing a problem and you don't necessarily look for the 0 powers. Well, multiply everything through by the 0. You're going to multiply this by 0, that by 0, that by 0, and that by 0. Anything times 0 is 0. So this is going to be w to the 0 power, x to the 0 power, y to the 0 power, and z to the 0 power. And then on the bottom, you're multiplying everybody by -4. Again, the -1, since it doesn't list a power, an exponent, it's got an exponent of 1. So this is going to be -1 to the -4, w to the -16, x to the +32, y to the +20, and z to the -60. All right, so I can do two things at once. The first thing I can do is say anything to the 0 power equals 1. So technically the top is going to be 1 times 1 times 1 times 1. So I can replace the top with 1. Now at the same time, I can move all my negative exponents from the bottom. So it's moving day for that one, moving day for that one, and moving day for my z. So this is going to be -1 to the +4 power, w to the +16 power, and z to the +60. And then on the bottom, it's just x to the 32 and y to the 20. All right, -1 times itself an even number of times gives me +1. Okay, so +1 times 1, still 1. And then these reds are not going to combine with these blues because they don't have the same base. W can't combine with X. So here's my final answer. All right, here's my last one. It might be a good idea to pause this one and try it on your own. All right, so if the whole fraction is to the -4 power, that means every part inside the fraction is receiving the -4. You're taking -4 times everybody on top. Remember, there's a 1 for my 2 here, so it's going to be 2 to the -2 times 1 1 times negative 4. Sorry, I'm really struggling with that too, so I'm going to stop talking about it. And then make sure you distribute the negative 4 to all these parts. All right. So that seems pretty overwhelming. But remember, you're just multiplying the little negative 4 times all these little numbers here. Exponent times exponent. So you're going to get negative 2 to the negative 4 power. You're going to get g to the positive 20. H to the negative 8. K to the positive 20. And then P to the negative 40. On the bottom, it's going to be 1 to the negative 4 power, g to the positive 28, h to the negative 32, k to the negative 28, and then m to the positive 16. Moving day for my negative exponents and nobody else. So the ones that stay are going to be g to the 20 up top, k to the 20 up top, g to the 28 on the bottom, m to the 16 on the bottom. Everybody else in red moves. So my negative 2 to the negative 4 becomes negative 2 to the positive 4 on the bottom. H to the negative 8 on top becomes h to the positive 8 on the bottom. P to the negative 40 on top becomes p to the 40 on the bottom. 1 to the negative 4 on the bottom becomes 1 to the positive 4 up top. H to the negative 32 on the bottom becomes h to the positive 32 on top. K to the negative 28 on the bottom becomes k to the positive 28 on top. All right, last move. 1 to the 4th power is equal to 1 times 1 times 1 times 1. Negative 2 to the 4th power becomes negative 2 times negative 2 times negative 2 times negative 2. That ends up being a positive 16. The g's, since you're dividing the two, you're going to subtract bigger 1 on bottom. So it's going to be g to the 8 on the bottom. H's, since there's division, you're going to subtract bigger 1 on top. It stays up top. The k's, they're both on the top, so you're going to add the exponent because it's multiplication of powers. 48's what's going to be left up top. And then the p to the 40 and the m to the 16, if they're positive, leave them. And that's your final answer. All right, guys. Hey, that was a beast of a video. Thank you for watching all the way through. I hope it was helpful for clarifying the stuff on negative exponents and zero exponents. Thanks for watching.